The year is 2099. Humans have been traveling in space for 150 years. Every part of our solar system has been explored. Missions to the nearest stars are on their way. But space travel has proved hazardous for human beings. And death lurks in the hostile environments of the planets and their moons. And so, through human ingenuity, a new breed of space explorer has been perfected. These are the SIMs, 5 super intelligent machines capable of operating in the most extreme and threatening conditions. Earthlink, the mighty spaceship which carries them across the void. On board is Lander, the transfer vehicle and sanctuary while on a mission. Inside are Legs, who tackles the most dangerous terrain. Wheels, the roving scientific detective. And Hover, the rescuer and scout. This team of trailblazers acts as agents for the human race, adventuring far into the solar system and beyond. Their destination, space. Jupiter, giant among planets, rules a collection of extraordinary moons. In 2097, the SIMs journey to Io, the strangest of all. Geysers hundreds of miles high belch choking sulfur dioxide. Lava flows, random and unpredictable, spill out over the sulfurous landscape of the most volcanic world so far discovered. Bombarded by harsh radiation, Io's seething surface is the most dangerous piece of real estate in the solar system. In one of their most hazardous missions, the SIMs were challenged by geysers as powerful as nuclear explosions, sulfur clouds of gas and particles, and a volcanic surface that could erupt at any time without warning. The SIMs were headed where humankind could never take even one small step.
We've been exploring the solar system for over 50 years. Now we have enough experience to tackle Io.
I have to fly through poisonous fumes of sulfur dioxide. Ugh!
You're lucky, Hover, able to fly from danger. I have to avoid floods of boiling hot sulfur.
You'll be all right, Wheels. We are immensely experienced, super-intelligent machines. Our half a century of development will make sure we can survive Io. This is our 5th mission to the Jupiter family. Familiar trip, but to unfamiliar territory. We've steered well clear of the horrendous radiation near Io on our earlier trips.
We've got Jupiter's strong magnetic field to deal with as well, you know.
We're smart enough to avoid the worst effects of that.
Cleared for takeoff. Rolling now. V1, V2, rotate. Lift off for the 500 million mile flight to Io.
Selecting transfer orbit for space station. Mission to Io docking at port 7. You're all going to need substantial re-engineering to make you robust enough for Io. We'll be here for some time.
Engineering is fitting me with new wheels. Hotspots on Io's surface are hundreds of degrees above boiling water. This wheel set is made from super strong ceramic polymers.
I get a new pair of shoes. The liquid sulfur is highly corrosive. The same material is being used to protect me as well.
And this time, I'm going to get both. I need super strong wheels and insulating feet. The problem is Io's surface, always changing. A safe landing place can turn into a searing cauldron very quickly.
Planet Earth can give us some idea of what to expect on Io, but only a pale shadow of reality. Earth has hot spots where molten rock pours out of the interior. Look, here in the Pacific, the Galapagos Islands. Volcanic islands like this have been built over hundreds of millions of years. Hawaii, in the center of the Pacific, has the most active volcano chain on Earth. On Io, like on Earth, volcanoes burst through weak spots on the surface. Now we're passing over the Klujetskoy volcano. The central vent is releasing poisonous sulfur fumes. It will all be far worse on Io. We'll be dealing with plumes of sulfur ash a couple of 100 miles high. On Earth, the molten rock breaks through, like here. The glowing, sticky lava can flow many miles. Io has a hot ocean of molten sulfur under its surface and has some of the greatest lava flows in the solar system. Its sulfur floods can stretch 500 miles. Preview over for today. Engineering work now completed. We are go for Earth-Jupiter orbital injection.
Computer now has prime trajectory acquisition. Main engine ignition.
So the SIMs began their 8-month voyage to Jupiter and its moon Io. Their last image of Earth would serve as a reminder of the calm sanctuary of their home planet as they headed for Io.
We have 500 million miles to go to Jupiter, past Mars and through the asteroid belt. Legs, use ion drive throughout.
Ion drive on.
It's exactly 100 years since the Galileo mission first reached Jupiter. Here are some details from the archive.
3 of Jupiter's 4 large moons are ice worlds: Callisto, Ganymede, and Europa. The 4th is the fiery volcanic world of Io, a seething cauldron of activity. Before the space age, little was known about Io's surface. It's so far away, no telescope could see any detail. It was the Voyager 1 spacecraft in 1979 that discovered plumes of sulfur jetting out of Io. In the late 1990s, the Galileo orbiter provided a feast of stunning images of Jupiter's moons, lands of ice and fire. Io is slightly larger than Earth's moon and dashes round its parent planet in just 42 hours. Skimming a little over 200,000 miles above Jupiter, Io is constantly racked by the titanic gravitational forces at work. The internal stresses release an awesome energy equivalent to that of 1 trillion light bulbs. This heat has created an ocean of hot sulfur below Io's surface.
1 trillion light bulbs. That's what I call a roasting.
With all that heat around, what kind of atmosphere do I get to fly in then?
It's not a proper atmosphere, but there are clouds of atoms and electrons, as well as sulfur dioxide, and there'll be strange lights in the sky.
Io's upper atmosphere glows with vivid colors, rather like Earth's auroras. Its parent planet, Jupiter, has a strong magnetic field. About every 10 hours, its most intense part sweeps past Io. Particles, carried along by the magnetism, crash into Io's atmosphere and make it glow.
It's the sulfur plumes and lava you'll need to avoid. The superheated sulfur dioxide jets out supersonically at 1,000 miles an hour. It soars 100 miles above Io. After sunset, it falls like snow. We have already identified about 200 sites where these erupting plumes can blow at any time. Look, here's archive of the same region of Io, images taken a few months apart. An entirely new dark spot has appeared. It's mainly lava spreading on top of the sulfur.
You mean we might get buried in sulfur?
Or swept away by a flood of hot lava.
Anything else we need to know?
Those sulfur dioxide geysers belch out a ton of matter every second. Some of it drifts along in Io's orbit, and there's a glowing cloud of sodium, too.
It's not too much of a problem for us. But on our final approach, I'll shut some systems down while we go through the strongest part of Jupiter's magnetism. For now, we can take it easy. An 8-month cruise to Jupiter.
Power up! We are now in Jupiter space, inbound at 400,000 miles from Io. Legs, initiate reverse thrust.
Rotating through 180 degrees. Fire main engine on my mark. 3, 2, 1. Ignition. Second course rotation coming up. Turning now. Io encounter trajectory acquired. The next few moments could be tricky. All systems will go to sleep mode as we pass through Jupiter's magnetic and particle radiation belts.
Once we're through, we must power up again at precisely the right moment to avoid crashing into Io.
Plan shut down in 2 seconds. Phew. There were a lot of high-speed electrons out there for a moment. We got the timing just right.
We've one more challenge. Our orbit goes near intense electricity flowing from Io to Jupiter.
I'm registering a current of 3 million amps. No wonder it lights up Io's sky.
We're keeping a safe distance.
5 seconds to go and counting. 3, 2, 1.
Some serious piloting there, Legs. Well done. Another hazard avoided. Now we need a safe touchdown for lander. Io has a hot side and a cool side. For safety, make your base in the cool zone.
No contest there. I'll chill out at a spot somewhere on the dark side.
Dark it won't be, with all that particle and volcanic activity. But cool, yes, and marginally safer.
This may take a while. We'll measure the surface temperature before going for a landing. This is the hot side. That big orange ring surrounds Pele, one of Io's largest volcanoes. Here's a close-up. That smaller red spot is next to the Marduk volcano. This is Io's quieter side, but all those dark spots are volcanoes. Going for a landing in a cool spot. Surface temperature here, minus 100 degrees. The distant sun will soon be eclipsed by Jupiter. We'll be in for a very cold night.
Oh, my new wheels feel good, but they've not been put to a real test yet.
Easy does the first step. Now we'll find out what it's like to be a tiny insect crawling over a giant pizza.
Oh, this sulfur powder is as fluffy as snow.
With 6-wheel drive, you should be okay.
There's a lot of sulfur dioxide around. From up here, I can see we're not far from a plume. Since there's not much action here, I'm off to explore over the horizon. Wind speeds are 600 miles an hour. Here's a new geyser firing off. Lander, I'm transmitting coordinates. You are more than 70 miles away, Hover. The SO2 is venting at 2,000 degrees at a rate of 50 tons an hour. Closing in for a detailed look. Temperature now 3,000 degrees and rising fast as I descend. Whoops! What a blast that was! Density and composition measurements successfully completed. Coming out before I suffer too much damage. Oh, the sun's gone behind Jupiter. I'm making a dash back to base. The temperature is plunging.
It's snowing.
This is frozen sulfur dioxide.
It's building up fast. Oh, legs! I'm stuck now.
Me too.
Ha ha! Both of you stuck this time. Sorry, guys. You're on your own.
Hey! Why did Hover leave us stuck in this mess?
A rescue's unnecessary. He knows that when the sun clears Jupiter, the snow will vanish. You'll just have to be patient, Wheels.
Amazing. Yes, it's nearly all gone already. Come on, now we can move. Let's get Lander to take us to Hover. Hover's found a real hotspot. Probably these rocky samples I'm taking now have only recently been brought to the surface.
We should try for some samples from deeper down. I'll try some blasts to loosen things up.
Then Hover can guide us to the next hotspot. Great stuff! It's all happening.
Follow me and Lander. We're heading for the hottest spot I've found so far. I register 700 degrees surface temperature.
Oh, it's certainly scorching. Quite a test for the ceramic tires. Let's see what this is.
My feet are hot. I hope I lost out.
I sense vibrations deep below us. There's an earthquake. I mean, Ioquake starting.
Molten sulfur is pouring out of a vent a couple of miles off. It's heading our way.
Great. We can get fresh samples from the hot sulfur ocean.
Guide us to it, Hover.
The sulfur lava is cooling rapidly.
Moving in to take a sample.
Be careful. Sulfur is a very odd material. It will change back to a liquid once it has cooled a bit more.
You're right. It's a liquid again. Ugh. It's swirling all around me.
But it's all flowing away. You'll be clear in a few moments. Then we can explore the place where that sulfur burst on the scene.
I found the outlet for the lava. Should be a great place for sampling.
Just so long as it's not about to go into action again.
Here we are. The lava gushes out through this tube.
I'm already reading a very high surface temperature.
Well, do we explore the tube? The continuing flows of molten sulfur have formed this long cavern.
And it brought up rocks from deep inside Io. Like this one.
Look at the strange deposits in the rock face here. Let's get some.
Are you picking up a vibration from deep down?
Yes, and it doesn't strain my logic circuits to recognize another Ioquake.
It's a new eruption, all right. And we're 3 miles in from the tube mouth.
Beat a hasty retreat. Lander, we have a problem.
Hasty? Ha, easier said than done. The tires can stand the heat, but they are slipping on the surface. Go on, legs! Run for it!
I'm going as fast as I can. Even these ceramic feet of mine are breaking up on these hot surfaces.
Lander, do you read me? Legs and wheels are 3 miles into a lava tube that's erupting. We must get them before the lava does. Time for acceptable risk action.
I copy, but abort before the 60-40 mark.
Tube threshold, SO2 reading very high. 1 mile in. Two miles. Legs in view. We'll pick you up on the way back, Legs. Wheels in sight.
I can't make it. Progress too slow.
Hang in there, Wheels. Landing now. Ramp going down. Board quickly, now! We have to stop for Legs on our way out.
The fireball of sulfur is only 500 yards away.
We're flying for survival. The race is on. SIMs against Io's liquid sulfur. To the exit.
Phew! Io is a kind of hell. It has Venus beaten on all counts.
Just made it. With a singed tail.
Welcome back. The journey home will give you time to cool off.
The SIM's investigation of fiery Io proved immensely valuable. Its internal composition became known for the first time, and much was learned about the powerful forces behind Io's spectacular natural fountains.